the ones who don't know what STEM means, it's science, technology, engineering, and math.
Good.
This is for Lo.
Well, thank you, everybody, for inviting us. This all started off with a little serendipity. Whoops, hang on here. Oh, I get to be that guy. Okay. We're here because I initially approached several members of the tech community for opportunity to do some interview on a research project that Aarush and I are doing. And we were graciously invited, and we'd like to thank you for that. Okay, let's get this show on the road because we've got a lot of things to talk about. Most of the time it's going to be Aarush talking. If you have questions, by all means, ask them. We'll be more than happy to stop in between and answer your questions. Now,
Wrong way.
oh, I'm going the wrong way. Up is down, down is up. Okay, got it. There we go. Visual impairment meets mathematics. We're bypassing institutional inertia through code-based workflows. Most of the commentary on that will be done by Aarush. I have some show and tell objects too. We'll get to those in a moment or six. I've been working with STEM students since the mid-1990s. I kind of fell into the job working with students who were just trying to pass courses that were analytical in nature. And well, nearly 30 years later, here we are. So that's what I'm doing right now. I prefer the term math coach because I believe coaching is more accurate to what I do. There's a story behind. I used to work for about 10 years with the University football team, and athletes really did respond to the idea of coaching. Now, Aarush, he's a computer science student, blind from birth, and Aarush, why don't you tell everybody about that?
Wow, okay, so many devices. I feel like a cyborg. Hi, everyone. Yeah, so my name is Aarush. As Tim said, I have a visual impairment. I was born with Leber congenital amaurosis. That's a mouthful. And so, yeah, I have light perception, and I can distinguish certain objects, but that's about it. And next up.
Oh, keep going. This is the same slide. You were born in India.
Yeah. Okay. So yeah, I was born in India in the early 2000s, and so accessibility, nobody knew what it meant. There were virtually no supports for people with visual impairments. There's no awareness, and awareness. When I say it's not just academic, it's also social awareness. You know, my mom, who's I think watching, hi Mom,
Yeah.
you know, when I was born, she was told a lot of things that aren't true. For example, being blind treated as something to be sympathetic about. You know, that, you know, we're sorry that, you know, he's blind, and, you know, things like that. But because of her resolution, because that's why I'm here, she not only, you know, having no kind of awareness and no knowledge of how to raise a blind student, decided that I would be not only be educated, but also be going to a mainstream school. And I'm very grateful to that because I learned early on that the world is not, in fact, inherently accessible. Oh, you're driving it, right?
I'm driving.
Okay, good.
On 92 rejections.
Yes, excellent. So yeah, it was a big thing, big commitment. 92 rejections, that's a big number, but that's what she said, and I trust her. So yeah, there's lots of rejections. People didn't want to teach a blind student. Lots of public ridicule. Okay, and then.
Oh, we have the evil.
Yes. Okay, this thing. I hate this. It sucks. So I eventually got admitted into a school, and of course I started out like many other blind students with Braille, and specifically this device is known as a Braille slate. How it works is you jam a sheet between the slate and then you press down to write dots with a stylus. It's very painful and very slow. So I hated it. Next thing, Braille.
Yep.
Yeah.
Now the Braille.
Yeah, and so I migrated to this in a few years later, which it was a lot better because I was able to keep up with it. Those who have seen or read Helen Keller's stuff might know what this is. So it was way faster. I was able to keep up with the students, but there were a few problems with this still. First of all, it's incredibly loud because it's like a typewriter. So you're in a class where the students are writing on a piece of paper and you just hear tick, tick, tick. It's very, very loud and annoying. Second of all, the problem with the Braille slate, same problem here, is nobody knows what you're writing. You either need to know Braille, and there were some teachers that were gracious enough to learn, or it was my mom that had to transcribe with like actual written text with a pen over top of my Braille writing, and that was not ideal at all. I also had to write my own textbooks because they were not available in Braille. And now, you know, back then when I used to do that, and I used to sometimes get a little bit frustrated, I would ask my mom or I would ask like my teachers, like, why do I have to do this? Like, I want to study it, I don't want to write it. And they would tell me something that is so like profound now and actually rings true. But back then, I would be very annoyed at it, and they would be like, oh, you know, it'll help you learn. You'll just write it again, it'll help you learn. I was like, oh, no, buy something. Yes, okay, next.
No, keep going, man. You're doing good.
Yeah, okay.
We're on the deep love of science.
Yeah, so I was very curious from an early age. Much to the chagrin of my family, I would ask way too many questions about the why and the how, and that's where my love of science came about. And so we have the... To learn science, of course, isn't just... So we just covered how I write and read, but there's also... It's a very visual subject, right? Like you have the digestive system, respiratory system, all of these things. So how do you represent them? So I'm going to keep saying her name, but my mom basically came up with what I call a homebrew system to represent these diagrams, which is she would use things like rice and pulses and all these different things to represent it, and then she would show it to me and I would memorize it and take it to school. And it would help me learn, and it would also help, you know, sometimes the teachers would come up to me and they were like, can I show this to the rest of the class? This is really good. Which is quite an interesting thing that we'll get into later.
Keep on going. I've got the current slide up now is Space Camp.
Yeah, well, I mean, yeah, I went to a space camp. That was fun. I got a scholarship. I was very fortunate to be receiving that, one of 3 students in India, and we did some cool activities. You can talk to me about that later. I won't get into it here, but you know, some cool photos.
Ready, steady, go. Down you go. Zip
Indeed.
lining. Okay, self-teaching, breaking code barriers.
Yeah, so in 5th grade, thank God, I had to no longer use Braille. I could use a computer. I was starting to learn computers at home. I had some, basically some education from some special visually impaired related NGOs. They would teach me how to use non-visual desktop access, NVDA. You'll hear that word quite a lot throughout this presentation. So the screen reader, and so finally I was allowed to take that to school. So everybody could keep up with what I was doing because it was not a different language altogether. So now, of course, this had its own challenges where we had to fight publishers to get the PDF things and all of that, but it was still a lot better. So around this time, because of aforementioned curiosity, whether to my advantage or detriment, that remains to be seen, I got interested in, I guess probably because I used it all the time, is how does this work? How does this computer work? How is this word processor working? So I wanted to learn programming. And I had a class in HTML, I think in my 5th or 6th grade, and that's where I got interested. And I was like, asked my friend, you know, let's learn Java. And 2 months later, no, let's not learn Java.
Wise choice.
So then I got into what are known as massive open online courses, or MOOCs, on Coursera, and I did a few of those on EDX and EDX and Coursera, yes. And I was fortunate to be one of the few blind students, one of the first blind students to actually do this. So was able to give them some accessibility feedback, and they implemented some policies to make sure that the courses are accessible. Should be some photos.
Yep. There's the verification.
Yep. because as it's said by Professor Dolores Umbridge, one must not tell lies. So here's a verification that I did these things.
Well, we know it's academia, so trust.
Indeed.
Of course, if you go to something like Retraction Watch, you can change your mind on that, but carrying on, I've got your Michigan slides up, and that means we're moving to the breaking point.
Yeah.
Describe destruction.
Meat and potatoes. I think that's a very Western term that I've learned. So in 10th grade, so until now, as I mentioned, I was using a computer. Now, so in 10th and 12th grade, we have these examinations that are not governed by the school. Instead, they're governed by a central board of education. So that's a very, it's a government level, it's a national level. And they thought that because I'm using a computer, I must be cheating, surely. So they didn't let me use one. We tried and tried, but they didn't. In the end, I had to use a scribe that I had never done before. By scribe, I mean I dictate whatever the answer is and somebody writes it for me. And obviously I have no way to verify, I have no way to tell what they're writing. So I was not used to this, and I didn't do well, especially in math, because I had a workflow where, my head to the computer, that brain to computer workflow, I wasn't able to do that. So because of this, in high school, I was not initially allowed to take these STEM courses that I wanted. So then we get to, okay.
Oh, you're good.
Yeah.
High
So
school forbids.
Okay. Yeah, so they forbade, me taking these electives. And so I gave them, it's a cool term because it's super dramatic. I call it an ultimatum. Dun, dun, dun. But actually, it's not that. It's, I took a huge risk. And I gave a challenge to myself that in 2 months that we have, the break between 10th and 11th, I would find a way to make this accessible and also represent it in a way that people that have sight can perceive it, so my teachers. So what I started with was I discovered, which it was not well known at the time, don't ask me why, that maths, Unicode math, which has been mentioned several times throughout this conference already, is supported by Microsoft Word. And I learned about that, and I learned basically Unicode math and how you write it in the equation editor. And so I figured out that, yeah, it's something that I can learn easily. Not easily, but I can do. And also something that if one of my professors looks at it, it looks quote-unquote normal. The only problem with this is that the NVDA screen reader did not, at the time, read all the Greek symbols, alpha, beta, theta, all of that stuff. So I had to write, and this was perhaps my first ever project implementing the MOOC learnings, a script that would manually, dynamically insert all of those symbols into the NVDA speech dictionary, so it would start reading them. And 2 months later, they let me use STEM. Or let me take up STEM,
You're
rather.
good. Yeah.
Okay.
Now we're on to fidelity.
Yeah. So I guess this is where I kind of met my, the intersect between my passion of inclusivity and passion of technology from the script I wrote. And I was fortunate enough to intern with Vedantu, which is an edtech platform in India. And it was quite big at the time because we had COVID and everybody was learning online. So I interned with them and helped them develop a workflow that would convert their course material. So they would usually hand it off in PDF files, but they would have an alternate HTML version for blind and visually impaired students.
I have your pictures up right now.
Yeah.
And moving on now
UVA.
to the University of Alberta.
Yeah. All right. So I knew from a very young age that I wanted to come abroad for my education because I've always had, as you could have maybe tell, that I have a very sort of practical, hands-on approach to learning. I like building and breaking things. I'm not very theoretical. And so that education suited me more. I also found this to be a good bridge of, very well known for AI research, and I was fortunate enough to get a scholarship as well. Then we have the...
Yep, no, we just finished that, and now we're moving on to the STEM accessibility gap.
So I was thankfully correct in that we it was more accessible. There were lots more supports. However, one thing that I learned, I guess the hard way, is that STEM accessibility, no matter where you go, India, Europe, Canada, is for a majority, it's not as well known, and therefore I experienced a huge gap, and this led to lots of challenges. 2.5 years of when I should have done 10 to 15 courses, I only did 2. I had lots of Fs on my transcript, withdrawals on my transcript, something that I'd never ever in my life seen before. So it's a pretty big shock. I was essentially a blind man by himself, no family here, and we were at one point financially destitute. I had to go home, and I didn't know if I would be coming back to continue the education. So now, when I say institutional inertia, what do I mean? What are some of those misconceptions?
We have the word doc fallacy.
Yes, indeed. So one of them is the word doc fallacy. People think that to make documents accessible, all you need is to convert a PDF to a Word. Especially back home, that's a huge misconception. And this is great if you're doing, I don't know, literature or arts, but when you have something like mathematics with diagrams, that it does not work. The second thing is the Braille.
Oh, okay. So let me borrow the microphone.
Yeah, you can take over for this one, actually.
Yeah? Well, I'll let you catch your breath a little bit, too. When I first met Aarush, this is actually a good place to dovetail in here. I first met Aarush when he was back in India. Him and I conversed over well, I'm going to call it Zoom, but it was more Google Meet than Zoom. And we realized that we both had common interests. I like to talk about mathematics. He likes to listen about mathematics. He likes to do math. I dabbled in computer science back in the 1990s, so I was somewhat conversant. Anybody here recognize Ada 95 as a language? Okay, so mission critical software, that kind of thing. Which is still around today, actually. You know, I think the latest standard for Ada is like 2025. It's really interesting stuff, but that's a trip off to the side. So I had to figure this out myself. How are we going to do this? And the school basically had someone 10, 12 years ago that worked, does what I do now, and then they retired. So institutional memory went away. So reinventing the wheel. So I got a couple of props here, some of the things we've tried out. This is a tactile diagram. I don't know if you can zoom in on that. You'd let me know if that's okay. So this is made on swell paper, also known as capsule paper. It's standard paper with a chemical coating that when you put black ink on it and expose it to light, a strong enough light, the photon energy will raise the plastic, and you can trace this with your fingers. So this is some test pictures that I've done for calculus. There's some Braille on here as well. I'm going to pass this around. Anybody who wants to take a look at it is welcome to do so. Pass it on to whoever wants to look at it. And then, of course, there's 3D printing. I do not have the mental capacity anymore to learn how to use Rhino 3D or anything else. So this one's cobbled off the internet. But for linear algebra, we have the intersection of two planes. Is this visible well? Yeah. Good, right on. And we've got vectors on here. So these are your orthogonal vectors coming off the plane. Anybody who knows cross products will understand that. I am going to investigate more of the aspect of 3D printing as time goes on, but it's a weighty topic, and I'm a little on the old side. So anyway, the bottom line is some things work well, some things don't. Here's an example of something that doesn't work. Aarush mentioned this to me. This is what happens when you copy a matrix from a PDF and you get useless noise. How does this help a student? I have no idea. Anybody got a clue what that's all about? I have no idea whatsoever. And yet this is what you're supposed to do. Doesn't work. Okay, I'm going to probably throw this back over to Aarush now. We're on the retrofit model. And that's, actually, you know what, let's just skip that, because you already basically talked about that.
Yeah.
So now we're on to, how did we get here today? So the school needed to address Aarush's particular problem. And by the way, we all have another student that I've been working with for the last year. So I've got 2 blind students that I'm helping, coaching, as it were, and maybe a third this fall. Anyway, the school had a poor reputation, a poor history for accommodating STEM students. We're trying to fix that up. So that's basically where I came in on this. And let's pop ahead here to a slide that I'm not getting. Ah, there we go. Oh, there's a good one. Yeah. Okay, here's truth. And I'm going to let Aarush talk about old dogs not wanting to learn new tricks. Here's your microphone.
Well, I mean, so in terms of when it comes to like mostly these misconceptions and the institutional inertia, I had to do, as I mentioned, a lot of advocacy for myself. And until and unless we had, it took us 2.5 years to figure out that, that the university to figure out, rather, I had it figured out, I think, that they don't have what they need, that they need help. And there are a few observations that I have as to why that might have been, but I'll touch upon that in the end. So a bit of a teaser for you there.
Okay, so right now we're on the topic of unnavigable graphical user interfaces to required software.
So is this the RARs?
Go ahead with the RARs.
Yeah, so there was, along with this academic course, the course material, there's also, oh, I was talking to the mic, there we go. There's also the matter of having some certain courses. For example, the computing science course that I took in assembly language used an assembly emulator called RISC-V. It's written in Java, again with a Java, and it was not accessible at all. So what I had to do was I had to write a bridge that was a command line bridge that would interact with this the API on the back end and basically give you a more accessible command line interface. And I did the same with an entity relationship diagram program, so you can basically just use JSON and it generates a JPG image for you.
Okay. I want to make a comment about testing methods and pitfalls galore.
Yes, here you go.
Okay, as you can see on the slide, I'm hinting at things don't always work well when it comes to testing. An anecdote is my other student was asked to use a scribe to write a math final exam. I believe it was either midterm or a final. It was an important exam. The scribe didn't understand mathematics. So not only did my student have to answer the questions, but my student also had to instruct the scribe on how to write the answers. And as I recall, that was a linear algebra course, so you have to tell him how to do, oh, look at all the math people cringing, how to do Gaussian elimination, step by step, that kind of thing. So yeah, we've had some moments where we've gone slapped our SMDH, to use as the young folks say. One of the other things too that we run into is graphic heavy exams where the acceptable alt text is probably not all that great. And one of the things that the accessibility department has kind of made plain is when it comes to exams, it's got to go back to the prof to provide the alt text. I really shouldn't be the one who's interpreting the graphic because it might give the game away or something. So Lord knows why that is. Anyway, so lecture slides, a jungle of graphics. This is something that I face all the time because I'm getting old material that I need to convert in some manner for usability for Aarush and my other student. And graphics are, well, they look great if you can see them, but let's face it, you can't always see them if you're blind. And how do you do that? Hand annotation on slides defies easy conversion. I use MathPix. I pay for MathPix myself to help me with conversion work. And it does a pretty good job, but sometimes you got to do things. So for instance, I also coach through the mathematics that I'm familiar with. And for instance, and this may be of benefit, like how do you decompose mathematics? So one of the instructors that we've interviewed was very good, quickly recognized that there's a pitfall with ambiguous narration. So oftentimes professors will get busy on the board writing the latest, greatest theorem, et cetera, and forget that, well, maybe people at the back can't see it, or maybe people at the front can't see it. People at the front being blind, of course. So how do you do that? So what I do is I take a top-down approach to narration. I would narrate this by starting off by telling the student that we're using a rational function. And then I'd specify the numerator. And then I would specify the denominator. Now this is a pretty simple function, but the point is that you have to think about it. How would a person who can't see what you're doing be able to interpret what you're doing? Okay, let's move back to Aarush because this is his story. We're on the code-based workflows slide, Aarush.
Oh, code-based workflows. So
You bet. That's the one where how do we break the cycle of forcing blind students into isolation?
Yeah. Oh, we have so many code-based workflows. Okay. So there's, in terms of when it comes to accessibility, there's this misconception with STEM that well, it's true to some extent, but that you need to know LaTeX if you're blind and you're taking a computing science course, right? And so, or a STEM course of any capacity. And it's easy to like say that, yeah, that's cool, we'll do that if you're a nerd like me and like many other people in this room. But what if there's, I have met people that are like, hey, I'm an arts major, I'm just taking this computing science course as an elective. And if you tell them, oh, yeah, actually, you need to learn Markdown and LaTeX and you need to do this other software, and they'll get scared away. No, people don't want to do that. Like, people don't want to be us. How do we simplify that? So one thing that I want to mention is that you don't need to learn it. We might have already mentioned this, but LaTeX or ASCII Math, which is an easier variant, along with Markdown, easily renders into accessible HTML that, as talked about in this in this conference already, is fully accessible with screen readers. With the one caveat, of course, being the image is alt text. So alt text is a little bit of a complicated topic, and we had some discussions about this earlier, is that detail, how much detail? You have a graph, right? And there could be an alt text that says, here's a graph with this and this points marked, this, and this part is shaded in white, this part is purple. I will get 0% out of it because I don't care what's shaded, guys. That's not part of the question. But then there's also, hey, there's a graph, and that's the alt text. Like the other day, I got an email that said the alt text. I'm not lying, guys. I'm honest. Actually, it said, I am an image. So how do you balance that? How do you prevent the cognitive overload, but at the same time, don't, kind of keep out the essential details? And that's what, when it comes down to alt text, because that's not up to LaTeX. Like the images are inserted separately into a document, so they have to be converted separately. And we'll get into some automation stuff about that in a bit here.
Pictures are worth 1,000 words.
Indeed, but I don't want to read 1,000 words, guys. Okay.
Cognitive overload wastes your time.
Yeah, we talked about this already.
Yeah, the sweet spot of structural and semantic descriptions.
Yep.
What is the sweet spot?
Give me what's relevant to the question and the concept. But it's hard. I don't have a definite answer. Well, I have kind of an answer, but we'll get into that solution in a bit.
Okay, so rule number 1 for how you write STEM is flexibility in communication.
Yes. So coming back to knowing LaTeX. So I did not know LaTeX that well in high school. But what I did was I communicated. I communicated with the prof and I said, hey, instead of representing square, if I write SQUARE or CUBE, is that okay for the time being? And they're like, yeah, okay, we know what you mean as long as you get the concept, right? And then eventually, when I started Unicode Math, I started transitioning into that more, and I learned LaTeX later on. But the point is, I didn't have to do that. So the thing is, it's not as much of a barrier as people think. Like, you just need to be more communicative and more flexible, whether you're a professor or a student.
Just as a comment,
Yeah.
when I first started working with the Erickson, grab the mic. I know I talk loud, but I'm not going to yell at everybody all the time. When I first started working with Aarush, I approached one of his professors, Professor Gassesi, actually, if you're listening. This is hats off to you. He was gracious enough to accept written responses, essentially written in ASCII math. That was perfectly acceptable for working in what we call Math 154, the first semester calculus. And in fairness, my interaction over the last 2 years with people in the mathematics department has been nothing but supportive. And I would like to acknowledge that. And when we've spoken to a couple of professors as part of our research project, and they're interested in us doing a form of this presentation for a learning seminar for some of the profs. So things are moving forward, and that's certainly good. Let's move on to tactile graphics. All right, you want to comment on this one?
Well, I think we already showed them, I guess.
Okay, well, this was the geometry toolkit.
Oh, yes. Surprisingly, I actually didn't know about this because I always had access to this back home. Is the geometry kit, which is basically a kit of all the tools that you might need to construct diagrams, 2D diagrams. So like the stylus, a scale, compass, a protractor, all of those things. And they had all braille labels, so to mark inches for the scale and things like that. But what I didn't know is that was a made in India product and actually wasn't available directly here, so it had to be imported, which we did actually. Oh, sorry, you wanted to say something?
Yeah, no, that's fine. I was going to add on there that we were fortunate to find someone who could get it to us in quick order.
Yes.
And that was a stroke of good luck. It could have taken forever to arrive.
Yeah. Okay.
Okay, we're into bypassing inaccessible GUIs. I'd like to also make a nod to IBM's SPSS as being completely useless when it comes to navigation, and Aarush has to do second semester statistics coming up. Guess what? The program is SPSS. R doesn't work. The graphical user interfaces to R don't work. How we did it in the first semester with R and R Commander, I did the graphics, the tables, and left it to my student to do the interpretation, and that's the best we could do. And we did quite well with it because the professors involved were also very understanding. Keeping on here, you got ER dot and RARS access.
Yep. I think we talked about this already.
Well, you did talk about RARS access. What about ER dot, the entity relationship program?
Yeah, I think I touched up on it a little bit, but yeah, so for database DBMS courses, the first week, and that's about the only accessible part of this course actually, the rest is just coding. So you are required to draw entity relationship diagrams to represent tables on the database. So that's obviously not accessible because they use something like draw.io. So I found this open source repository, and then I made it more accessible and up to date with PIP standards and all of that stuff. To basically where you can write YAML or JSON code, and you can use the Python library, and it renders into a nice, clean looking JPG file that you can hand into your professor.
Okay, let's look at the future. We are building solutions.
Okay, so...
All right, cross-platform STEM reader.
Yes, so I am currently working on, as part of the research, a STEM reader. So we were testing out the latest enhancements in LuaTech, thanks to the TX user group, once again. And I found out that, as mentioned in this conference already, Firefox is just about the best browser to read this stuff, but Chromium, yeah, good luck. And there aren't really that good cross-platform PDF readers that aren't either janky or otherwise not very good with screen readers. So this is what I'm working on currently, is one reader that can read STEM, whether that's HTML or even the new LuaTech PDF, the accessible PDF with mathematics, which of course is accessible but also looks as it should look to anybody else if they're looking at the screen. And the next one is the writer, right?
Natural language writer.
Yes, so as I was touching up on before, people don't necessarily want to learn LaTeX. People get scared. And as I was mentioning, the thing I did in school where I would just write it in English language, well, I mean, we could make that better, right? Like, yes, you have the understanding with the professor, but that's just the one professor. So what I'm doing currently is, because I like to see myself at the intersection of AI technology and also like with the accessibility context, is writing a natural language editor where you can do the same thing, where if you don't want to use, well, of course you want to use LaTeX Markdown and ASCII math, all of that is supported. But if you instead want to simply use English to explain what it is that you want to be represented in the equation, you can do that, and then natural language processing, the model interprets that on the back end, converts it into LaTeX, and that LaTeX is rendered as HTML. So, you know, that further lowers the barrier of entry, is my hope.
Cool. Let's talk about easing into automation, structure OCR via MathPix.
Okay, so I'll just mention a bit about structural OCR, and then I'll hand it to you.
There.
So what does structural OCR mean? So OCR, object character recognition, has been around for many, many years, and of course it's a way to get text off of images. But when we say structural OCR, that is what you need to OCR anything STEM related, or you'll get the garbage that we saw on the slides where it doesn't make any sense. Because it needs to know how things are placed, not just the things that are on the screen. So it needs to know headings and layouts and all of that. And so one of those things is MathPix that does that really well. And I think you touched up on this already.
Yeah, we have. Just touch briefly on human verification, because from my perspective as well, I need to verify converted material, and that's a tedious job.
Yes, so verification is of course always needed. You know, it's an LLM, guys. It's not AGI. So the thing is, yeah, so you do need to verify, especially with image descriptions, because that, as I said, is a separate part of accessibility. So I view it as two different distinct part of making STEM accessible. Is one is the OCR, and second is describing any present diagrams. So yes, verify those descriptions. But the thing is, automation turns that from 100% of your work of labor into 10%, and that's a huge leap.
Okay, let me have the microphone. I want to talk on a couple slides.
Yes.
Thank you. Okay, so as far as my workflow goes, as someone who's trying to produce materials for Aarush and my other student, and perhaps a third student this fall, is entirely dependent on what I'm handed. In the perfect world, it's submit a PDF to MathPix, then I can export it into a number of different formats. In particular, the thing to keep in mind is Aarush is from Delhi. You've heard his story. My other student is from North America, from here in Alberta actually, and his experience as a blind student is 180 degrees different than Aarush is, and that requires flexibility. I guess the caution I would give to anybody involved with this is you must not assume every student is equally fluent in Braille or any other technology, because Aarush, compared to my other student when it comes to reading Braille, there's no comparison. My other student can rip through Braille. I was going to bring an example of some Braille conversions, but unfortunately my other student's in the midst of moving, so I couldn't get that from him. But the point is, Western Europe, Western culture, Western, like North America, Mexico, Canada, US, you can't take your assumptions about students from those locales and pass it on to people from other parts in the world, because you're going to hurt yourself and your student's going to get held back. Because I have much to say on that, but that's not the point of this discussion. Just don't assume anything. People are highly variable. Worst case scenario is you get something that's a horrible little mess and you end up rewriting the thing from scratch. And I ain't got time for that. I'm sorry to use the meme, but it is quite the piece of work. And enough said on that. Here's an example of things that you encounter, and this is an example from computer science. Here we have from, what was the assembly language course, 269?
229.
Okay, 229?
Yes.
Yeah, so anyway, this is, and I would give credit to the author of this, but I couldn't find out who actually made the graph. But how do you convert that? And you'll notice the red text where you have some binary, you have some base 10, you have the floor function, you have all this. So I asked Gemini to produce a succinct alt text. And this is what you get. And I made sure I used the word succinct. And this, well, you have to know your student. So intervention may be required depending on who's going to be reading it. But again, that's a hindrance because in a large environment where you have many students, well, what are you going to do? So I have another example of this. Here's also from a course. So here's a binary tree, AVL tree. This is what Gemini said. Again, intervention is required, and that's a time sink. Just sucks the life out of you. Well, maybe not quite that dramatic, but you get the point. And then, what are you doing with these asterisks? Apparently it means something to Gemini, but whatever. Anyway, moving on. What works well? A clean conversion to a desired format. Instructors, profs, keep your graphics simple because then they're easy to describe. You are not a graphics designer. Don't pretend to be one. You're a PhD in mathematics, act like one. No extravagant page layouts. Stating the obvious, I guess, there. So I just, and by the way, this slide deck is done with LaTeX Talk, by the way. Took me no time at all to pick up on how to use that. There's certain characteristics here. This is from essentially a 5-page formula sheet for Introduction to Statistics. It's 5 pages. Originally it was 4, but I put a table of contents on there as well because students keep this, they never print this. I've asked students, print your formula sheet. They never do. So it's all on a tablet or all on a laptop. So I figured, oh, okay, here's a clickable link for to get you to where you want to be. Away you go. But you'll notice I'm using section numbers. I'm using bullet points. This is a table, in case you hadn't figured that out. The point is, and Aarush can speak to this, and I'm going to let you do it, Aarush.
Yes.
The importance of navigational markers.
Yes. So as I touched up on in the structural OCR topic, this is why you need that structure, because without those navigational markers, it's just a huge blob of text. And even if you make that blob of text make sense, now what am I supposed to do? Arrow, down arrow like 20,000 times through a 5,000 long book? Yeah, no, that's not happening. So that's why we have markers, we have headings, we have lists, because screen readers have built-in navigation keys that let you navigate through them. So to the next heading, to the previous heading, things like that. Okay, I think up next is
that's
me
fine.
again. Yeah.
We're down to, we got about 5 minutes left.
Okay.
So,
you talk about the app quickly?
well, I've got the VED AI slide up here. Keep it short.
Yeah, so quick, people can talk to me about this more. It's a bit of a shameless plug, but as part of my research, I'm, along with a friend of mine, we're building this app that essentially turns all of this we just mentioned into a one-click solution. So yes, in goes a PDF, out comes accessible HTML or Word file, and it does both the structural OCR and the image description. And quickly talk about image maps here.
That's where we're at. Go.
So image maps, and this is my solution to making alt text better. And again, I'll keep it short here, but people can talk to me about this more later. What we do is we turn the image, instead of text, into a virtual grid that you can navigate with a screen reader. So for example, it'd be like you're at 0, 0, and then I press right arrow, it goes to 1, 0, up arrow is 1, 1. So it turns that into a grid, and using some machine learning concepts, object segmentation and classification, we separate the different elements of the image, so you can basically walk around the image with the screen reader and inspect it. So this way you don't get the full blast in your ear from the screen reader.
Okay, let me borrow that microphone again.
Yeah.
Okay, so don't give the game away too much. This is your intellectual property here, big guy. I do want to make a comment. Earlier I said SPSS and R and the interfaces to R were inaccessible. I've been watching the JASP project very closely, and there's 2 links at the bottom of this page. They are involved with making this an accessible interface to R, and I'm quite interested in the success of this project because it'll make my job helping with statistics much easier. Moving forward, human aspects, we're just going to do a quick summary here. Thoughtful narration. If you're a prof in front of the board, think about what you're going to say and, you know, consider the person who either can't see it from the back of the room or just can't see it, period. Choose your words carefully. Beware of the picture is worth 1,000 words because that ain't going to fit in an alt text environment. Replacing visuals purely with text is often reductive. Aarush has got much to say on that. If you want to pin him down later, by all means, go ahead and do that. If you're going to design examples, keep in mind universal accessibility. Technical aspects, of course, why we're here today, text-to-speech and tag PDFs. Various markdown languages are useful. Like, for instance, just quickly touch on, Aarush liked Markdown for a lot of the things I've done for his benefit. My other student preferred HTML. I can do both as long as I have access to someplace I can start with. 3D printing, tactile solutions, I've sent those around. Cross-platform PDF readers. Aarush, I'll give you a chance to comment on the last one here, why you should care. We don't have to rely on humanitarian advocacy.
So, so it's a bit of a contradictory title because so it says why you shouldn't have to care about accessibility, and the question you might be asking me, rightly so, is what? I thought that was the point of this talk, and you'd be correct. But why I say this is because we have made significant progress in accessibility, like even before this amazing PDF initiative. But even then, I've seen so much hesitance from professors and different people in accessibility. And why is that? I think that is because accessibility still feels extra. It feels like that they have to take additional steps to make a different document for different people. And I think as, you know, as a developer, and I'm surrounded by lots of talented developers, so it's my appeal to everybody because I think it rests on our shoulders and it is our responsibility to ensure that that is the first thing that changes, that people don't think that this is something that they need to do that's additional, that we make the back end so robust and accessible that me or any other blind student can just approach the professor and say, hey, the document PDF file you're giving other students, give me that one. It works just as fine for me as well. That for me is inclusion. And I think the only way to achieve that is together. Thank you.
Well done, Aarush. Thank you very much. I feel quite privileged to be part of this project, by the way. After half of my working life has been working with students, and this is meaningful work. And sometimes it's really hard to find meaningful work, and I'm enjoying it. Okay, so I know we've ran out of time. We're 45 minutes in. Just to wrap up, here's some contact information. Aarush has a YouTube channel. There's a few other things going on there. And here's how you can get a hold of us, and I'm sure Aarush would be happy to answer any questions you have. And I know it's lunchtime. Eric wants us to be quiet. So get up here, Eric. Take over. Say the things you need to say.
Well, we'll have time for some questions.
You've got 8 minutes for questions.
Yeah.
We have time for questions?
You've got 8 minutes.
Oh, okay. Okay. All right. We have a question, Aarush.
Yeah.
Yes.
Hi, I'm John Bowman, and I just wanted to make a remark about the graphs. Trying to deconstruct the PDFs and figure out structure from the graph and how to. It seems. I mean, I guess my question is, where do the graphs come from? I mean, presumably they're not hand drawn, or if they're JPEGs or something, that's going to be difficult. It seems that it would be better to do this deconstruction at a higher level. Like if this graph was developed with software, that you drew a cone and then a sphere, and if you have a software description of this, it seems that's the place where you want to put in the alt text that does the description, rather than trying to do it after the fact when everything all jumbled together. It's the same issue that I was talking to Frank Middlebach about this with PDF. You want to do this at the source level, LaTeX level, not afterwards when you have a PDF document trying to
Well,
deconstruct the structure.
one of the things that we were going to talk about was the amount of effort it takes to retrofit instructional materials. It's not an insignificant task when you're always going back to existent material to convert it. And if you can make it, I would say perfect, as we all know in mathematics writing, nothing is ever perfect. How many iterations through a book do you do? It's tedious work. So if you get it right the first time when you make it, that's great. Aarush, you got something to say about that?
Yes, actually. So I think that's a very good point, and I agree with you. And that's what I was saying, that accessibility should be baked in. But I think everybody knows that there are always going to be cases when that is not the case, and people have, and so taking that into account, as well as the fact that we make this easy. That's why in my automation workflow, I'm building a system that can take those PDF files and deconstruct the JPEG graphs. It's harder, yes, it involves a bit more mathematics on the machine learning side, I guess I could say. But the thing is that that takes into account that, okay, if people have already done this, where they've done it in software, as you say, which I hope more people do, but if they've done it, then well and great. But if they haven't, then we have this fallback that, so you can just upload this PDF file and it gives you everything that you need to read the file.
So I see someone picking up on this right now and going, ooh, time to vibe code. Anybody? Well, I'm sure people have been hanging around the LaTeX subgroup on Reddit and all about vibe coded apps. I'm looking at the audience for people. I know some of you have come. Oh, the myriad number of new ways to write LaTeX that people have vibe coded. They throw it up on Reddit. Oh, come try my new app, and they just had AI write all the code. Yeah, go to the go to the LaTeX subreddit on Reddit and look at all the new replacements for, hey, I've made overleaf, but I made it better, and I did it in my spare time, and I'm a brilliant coder. And then, of course, people go, you vibe coded that, right? So vibe coding is the current buzzword for, I'm going to get AI to write code, and I'm going to be a superstar. You know what I'm talking about, Max. Yeah. Anybody else got questions?
Yes.
Because Aarush has got lots to say. If you're curious, go ahead and ask. Otherwise, pin him down later. Well, not literally. But,
You can do it literally
Boris.
too. I don't mind.
Go ahead. Oh, Boris is going to get your question here.
All right.
Yeah, I was okay on the chat. I just wanted to thank you. On the chat, I just want to say that a lot of people are commenting the talks and say that it's absolutely interesting and very inspiring. So it
Thank
was
you.
very good. And if you have time, just a very short remark. You talked about scribes, and it reminded me of the story that one of the probably best mathematicians of all times, Leonard Euler, he lost his sight at the end of his life. And because he was technically an employee of Russian government, he was given a scribe. But the scribe did not know anything about math. So being a genius, Euler taught the scribe math, it was and left several dozen new papers with the scribe. I just can't understand how he did it.
Commentary? Or just more of the same?
Yeah. Do you have
Yep, here we go.
comments?
There's your microphone.
So.
Yep.
So your question is what is it?
No, it was a
Yeah, because that was like a comment. Yeah, I mean, I definitely agree. Like, I remember when I took, I took the SATs, and I think that one time it was a huge struggle to let them, because they're like, no, actually, you can't have someone scribe for you that you know. So you're supposed to find somebody random in like a month that also knows math, that knows you, and write an exam. That's great, guys. Well thought out.
I want to make a comment.
Yeah, go ahead.
I want to tell you a quick anecdote. My other student Oh, how does that story go? On the topic of finding scribes and the scribe not knowing how to do mathematics. Oh, I know what it was. So there's software that's involved in the accessibility world to allow students to schedule their own exam schedule, look after your own timetabling, essentially, except it's not accessible. No one thought to test it. In engineering, isn't the whole idea is to hack together a prototype and test the heck out of it? Doesn't that make sense? No, that's not something that's always happening. And it came to a head here this past year where all of a sudden you go, well, why everybody's missing out on their exams? Because you can't use the software. There's a certain lackadaisical or laissez-faire attitude towards, we'll do all right. Well, anyway. Anybody else got questions? Are we going to be done?
Yeah.
Okay. Oh, Max, go ahead.
Yeah, so.
Here, let's do that.
Hi, so I'm Max Chonoff. One of my questions is, a lot of your presentation was about like making sure to check with the user and like personalization and like making sure that it's like what they want. So for me, I'm just blindly posting random PDFs on the internet. So I don't have any users, I'm just posting it there. So what should I be doing to make it accessible? Should I just enable tagging, hope everything goes well? Is there anything specific I should be checking?
You should test it.
Okay, and then like I should just test with a screen reader, make sure it works through, and that's
Well,
I can figure it out.
If you're using Windows, you just load NVDA and listen to it. I use Linux.
So
and
do I, yeah.
Orca is getting much better at it.
Yeah.
I was quite pleasantly surprised. I use the Tumbleweed rolling distribution from OpenSUSE, and I believe Tristan here in the audience is also, there he is in the back. Us Linux people, we have to navigate things a little bit more interestingly, but that software is out there, but it gets sort of hidden sometimes, I think. Especially if you don't want to pay the Microsoft tax.
We got time for a small comment on this?
Yes, well, thank you.
And I think we want to go for
Okay.
lunch.
Yeah.
Everyone's hungry.
Okay.
All hungry.
Yeah, so I won't keep you guys for long, but just to answer Max, so a few things. So first, of course, this conference is, a big topic is how to tag PDFs efficiently. So if you take that away, but we also, the point of this research is to actually document that open source is how do you make files accessible, right? So that will be made available and I can send it to you if you'd like. But a good discussion that I had with both Frank and Carl actually is and I've been thinking about this as part of my research is how do we actually establish a network, a feedback loop, if you will, between people that are users and people that are implementers, or even people like professors, Somebody could be like, hey, I taught this cool calculus concept in class and we had a blind student and he actually understood it when I vocalized it this way, like some forum to share that. So yeah, that's something I'm thinking about. So we'll see how it goes, but yeah.
Thank you.
Thank you.
Okay, this is the end of my chairing session, and Aarush will take it over.
Oh, more talking.
And yeah, but that's after lunch. We're going first to lunch, and we'll be back at 30:45.